Hello and welcome back to JD's Science Prep. Today we are going to be discussing ray diagrams for thin lenses. So remember, ray diagrams for thin lenses, this is not for curved mirrors. I do have another video for that too, if you do want to take a look at that. So to start, there are two main types of thin lenses that we're going to discuss in this video. And number one, we have the converging lens. Whoops, wrong marker. Number one is the converging lens. Okay, so this type of lens is going to make light converge once it passes through the lens. Okay, so unlike curved mirrors, this is considered to be a convex lens with the shape, and we have the middle of the lens is where the thick point is. So the middle of the lens is thicker than the edges. Perfect. Okay. So that is a converging lens or a convex lens. And next up, lens number two, we have a diverging lens. So unlike a converging lens, a diverging lens is going to make light diverge once it passes through it. And this is considered to be a concave lens based on the shape. And again, the middle of the lens will be thinner or more narrow than the edges. So the middle is more narrow than the edges. Perfect. So those are the two types of lenses we're going to go through here. So while we're drawing ray diagrams, similar to curved mirrors, there are three rules that we can apply. So rule number one, it says that ray number one will begin parallel to the principal axis and refract through F once it hits the lens. Ray number two will go through the secondary focal point, so we will be labeling a ray diagram before we get into some examples. So we're going to learn what the primary focal point and the secondary focal point are, as well as what 2F stands for. But back to our rules. So again, ray number two will go through the secondary focal point or travel along that path if the lens is diverging, and refract parallel once it hits the lens. And finally, rule number three, it says ray number three will travel through the optical center and continue along that path. Okay, so let's label a ray diagram here. So first off, we have to label what type of lens we have. So if you were paying attention, you should know that this is going to be a converging lens because our middle is thicker than our edges. Okay, so for converging lenses, our primary focal point will always be on the opposite side of the lens compared to our object. So remember, if you are familiar with our curved mirror video, you will know that when we're drawing these ray diagrams, an arrow represents our object. Okay, so the primary focal point will be on the opposite side of the lens compared to the object, and our secondary focal point will be on the same side of the lens as the object. So you will notice we have two ticks on either side of our lens here, and those two ticks represent something called 2F on either side. So 2F. And all that is, it's just double the distance of the focal point on either side of the lens. It's comparable to the center of curvature for curved mirrors, if that makes sense. Okay, so we have everything except one labeled. If you take a look at right in the middle of our lens here, where our principal axis, so remember, so the principal axis is this horizontal line where everything can be found, where our principal axis and middle of our lens meet. So roughly right here, this can be described as our optical center. So that's our optical center. It's just the geometric center of our ray diagram. Okay. Okay, I think we have everything labeled. We can start to get into some examples here. So let's scroll down. Okay, this looks mighty familiar to our diagram that we just labeled. So again, we have a converging lens, and we just have to follow some rules now. So rule number one says that our first ray is going to run parallel to our principal axis. So we can draw a ray that runs from the top of our object parallel to our lens. And I'm just going to label quickly what we need. So remember, primary focal is on the opposite side of the lens, and secondary focal will be on the same side as the object of the lens. And we have our two F's. Whoops. So our two F's. Perfect. Okay. And it's going to, our first ray is going to refract through our primary focal here. Let me just line this up so it's perfect. There we go. Okay. And it should run just like that. So ray number one is complete. I might just draw a direction of light as well. Perfect. Our second ray is going to run through our secondary focal point. So something like this, and as soon as it hits the lens, it's going to refract parallel to our principal axis. So it should look something like this. And finally, our third and final rule that we can follow. Our third ray is going to travel through the optical center along the exact same path. Okay. So top of our object, optical center, and it should look something like that. Perfect. Okay, let's draw this final ray. And it's not exactly perfect in the optical center here, as you can see, but you should get the idea. Our image is going to end up where all three of these rays intersect. And I'm just going to erase 2F so it's a little bit more clear. Right about there is where our image is going to be. Awesome. Okay, so we have our image drawn, but we still should discuss what some characteristics of this image should be. So I'll just circle it and label it as our image. So if the image is found on the opposite side of the lens compared to the object, it is a real image. So a real image. This differs from curved mirrors, so please remember that as you're doing these examples. And we can decide if it's upright or inverted. So since it is upside down, we can write it is inverted. Okay. Our next thing we can write down is larger or smaller. This one's a little bit tricky to see. They're pretty similar in size, but I would say that this is larger, slightly larger. And finally, for location, we can just write behind 2f. So behind 2f. Okay. So again, if it's on the opposite side of the lens compared to the object, it's going to be real. Okay, so that was example number 1. Let's get into example number 2. It's going to look a little bit different here. So this time we have a different type of lens. This is going to be a diverging lens. So a diverging lens, okay? And our primary and secondary focals are going to actually switch with a diverging lens. Okay, so our primary is going to be on the same side of the lens as the object, and our secondary is going to be on the opposite side, and our 2f's stay the same. So it should look something like that. We have our optical center there right in the middle of our diverging lens. Okay, so let's follow some rules here. So again, the rules can still be followed. They'll just be represented a little bit differently. So our first rule is our first ray will run parallel to the diverging lens, and it's actually going to refract in at the same path as the primary focal. Okay, so when you have a ray that refracts at the same angle as the primary focal, which is, it's tough to represent here. I guess you can see where my ruler is lined up. I'll draw a little arrow. Okay, we can actually backtrack this ray, but if you have to backtrack a ray, you guys, make sure you use dotted lines. So if you have to backtrack along the same side of the lens as your object, your lines have to be dotted here. Okay, so again, it's kind of opposite of the curved mirrors, where if a ray went into the mirror, they had to be dotted. For lenses, if a ray reflects back on the same side as the object, that line has to be a dotted line. Okay, so that is rule number 1 for a diverging lens. Let's take a look at rule number 2 here. I'm just going to erase a couple lines. There we go, a little bit neater. So rule 2, we can line up from the top of our object to our secondary focal point. Okay, and we'll have a ray. Oops, I'm still in eraser mode here. That's my bad. Okay, whereabouts was I? Let's just undo. There we go. That's better. So let's line up again the top of the object with the secondary focal, and we can draw a ray making its way towards the lens, and as soon as it hits the lens, it is going to refract parallel. Okay, so refract parallel like that. And again, we're going to have to backtrack here. So that line drawn on the same side of the lens should be dotted. It should look something like that. Okay, and I'm just going to redraw this line here. It's a little bit off. There, it should look something like that. Perfect. Okay, so we have rule number 2 now, which is all followed. And the last one we can follow is just through the optical center. So from the top of the object through the optical center, and remember, it just runs along the same path when it hits the lens. It doesn't refract at all. Just like that. And you should start to see where our image is going to show up. So all 3 lines intersect right there. Okay, so I'll just circle it, make it a little bit more clear. There's a lot of lines going on there. But all three lines intersect right there, and that means our image will go from the principal axis to that intersection. And just quickly pointing something out as well. For the diverging lenses, remember light is going to diverge from one another. So all three of these rays are moving in different directions. So they will never intersect on this ray diagram, which means that our image has to be on the same side of the lens as our object is. Okay. So before we cut this video, let's just draw or write out some characteristics. Since our image is on the same side of the lens as our object, this is going to be a virtual image. It's definitely smaller. For location, we can write between F and the lens. And finally, it is just upright, right side up. Awesome. So that is a little tutorial on ray diagrams for lenses, or for thin lenses. All right, I hope this video has helped.